Hi everyone, welcome to this paper 2 higher question from 2017. L is the circle with the equation x squared plus y squared equals 4. Point P given there is a point on that circle, and we have to find the equation of the tangent to L at the point P. So in other words, what this means, if I do a little sketch here just to show you what's going on, we have a circle here because x squared plus y squared with nothing else apart from squaring the x and squaring the y. That denotes a circle at center being the origin. So the center at the circle is the origin. The radius of the circle is, the radius squared is 4. So the radius of the circle is 2. We don't need to know that. We're not going to use it, but just gives you an idea about this, the relative size of the thing. Now point P, both x and y coordinates are positive, so point P is going to be in this first quadrant where both x and y coordinates are positive. So let's just bung it down somewhere there. Doesn't need to be precise, doesn't need to be accurate. Now what we have there, the tangent, remember, is a line which touches a circle or a curve at one point and one point only. In other words, something like this. Now we need to get the equation of this tangent. How are we going to get there? I would suggest the best thing to do is remembering that we have one of the circle theorems dictates that the tangent meets a radius of a circle at 90 degrees. So on there I can draw the radius at P going back to its origin, back to its circle, which is the origin. Now that if we can find the gradient of the radius, we can then take the negative reciprocal and then we'd have the gradient of the tangent. So let's look at that. So what we have here, if I just draw that diagram a little better. So there's P, there's the origin. The x distance here is 3 over 2. The y distance is root 7 over 2. So the gradient of that radius at P is root 7 over 2 divided by 3 over 2. So the gradient of the radius, let's call it MR, right? Gradient of the radius is the change in y, root 7 over 2, divided by the change in x, which is 3 over 2. Right? So we can simplify that by multiplying top and bottom by 2. So in other words, times 2 on the top, times 2 on the bottom. That will cancel there, and that will cancel there, leaving you with root 7 over 3. So the gradient of the radius is root 7 over 3. We can then find the gradient of the tangent. Let's call that m suffix t. Now that would be the negative reciprocal of the gradient of the radius, because remember, they're going to be meeting at 90 degrees. In other words, they are perpendicular. So mt would be, let's take the reciprocal first and then negate it. In other words, if it's positive, it now becomes negative, and vice versa if it's the other way around. So now we can form an equation, start to form the equation that we're looking for. Well, actually, there are two ways of doing this depending on where you've got to in your scheme of work. Okay, so what I would suggest is that we go and do two options here. Now the first one, if you've been shown that y minus y1 equals m lots of x minus x1, that is the way in which you can find the equation. So in other words, your y1 and your x1 come from the point P. So what we have is y minus y1. Well, y1 is the root 7 over 2. In other words, the y coordinate of the given point equals m. Well, in this case, m is the value of the gradient for the tangent. That's negative 3 over root 7. And that's going to multiply by generic x minus the x coordinate of our point. Okay? Now, that is an acceptable solution for this question. If you haven't been taught that method, you'll go back to y equals mx plus c. Now I know that I'm going to substitute here. I'm going to substitute my x and y values, one of which, the y value, is root 7 over 2. So I know that there's a bit of mathematics involving, because we're going to find out the value of c. Right? The whole point of doing this is this method here. Is we need to find the unknown c. In other words, where does this tangent cut the y into the y-axis? So I know that I'm better off, because I'm doing some mathematics with root 7. My gradient of the tangent has root 7 as the denominator, but my y value of the coordinate has got root 7 on the top. So I'm just going to do a little cheeky rationalization. In other words, I'm going to multiply top and bottom by root 7. That's going to give me negative 3 root 7 over root 7 times root 7, which is, of course, 7. So I now have the rationalized form of the gradient of the tangent. So that's going to go in there. I'm going to use my x and y from the point P. So here we go. I'm substituting in the y, root 7 over 2. Now I'm going to equals m, the gradient of the tangent, in its rationalized form, negative 3 root 7 over 7. Lots of x. Well, the x is 3 over 2. So it's gradient times the x value plus c. Now I need to rearrange that to work out my value of c. I think I've just gone across there. So let me just put that up there. So what we now have, let's just simplify this. So we've got root 7 over 2. 3 3s are 9, so it's negative 9 root 7 over 7. Sorry, 2 times 7, which is 14. Beg your pardon, that's 14 plus c. Now I add 9 root 7 over 14 to both sides. So that's going to give me, so this is root 7 over 2 plus 9 root 7 over 14. That will equal c, because I've added 9 root 7 over 14 to both sides. This is what I'm getting for c. Okay. Now, what I would do there, I would factorize my root 7. So I then divide out my root 7, will leave me a half plus 9 over 14 equals c. Okay. So that would be a half is 7 over 14 plus 9 over 14. What's a root 7? So that's 9 and 7 is 16 over 14, lots of root 7. 16 and 14, they're both even numbers, so that will be 8 over 7, lots of root 7. So I've then got my y-intercept, so my final answer on this method, which I'll grant you is a little bit more involved, would be that y equals m. I could use the negative 3 over root 7 version. It really doesn't matter. So negative 3 over root 7. This is my mx plus my c value, which is 8 sevenths root 7. So there is your final answer for the y equals mx plus c form. So just to recap, y minus y1 equals m lots of x minus x1. That answer is there. And the y equals mx plus c version is there. Hope that makes sense. If it doesn't, please drop me an email and I'll deal with it from there. Thank you very much.